Welcome guys, I'm going to today show you how I make the holes inside of our caps for our bottles. So here's our caps. The tricky part with these is we can drill them, but the problem becomes is that this part right here is rubberized, and if we just drill these will close off. So we have to actually burn through them, and then this part has to be poked through. Okay, so we tried multiple different ways. This seems to be the best way it works. I do use an industrial robot. This is an a.n.bees 120. The reason I use it, it is a little bit of an overkill, I admit, but use what you got. So I got this and I had fun programming it, so that's what I use. So on this part, this is going to be the heater. So this is like a branding heater, and then I made two custom pegs for it to actually make the right hole. And then on this side, I just have a fan that's set up to blow off, to cool it off. Right here is a mess of wires, which is an industrial controller that's controlling the heat. So this guy is turning the heater on, and then on the back, as you can see, there's well, you can't see, but there's a probe in here. Now this all is enclosed in basically a channel stainless, because we're raising this up to about 900 degrees Fahrenheit, and then this has a suction fan on it. My suction fan is a very sophisticated, basically an exhaust fan used for bathrooms, and then that's the actual part that's using the exhaust, which is just a, as you can see, post office box. All right, so what we're going to do is we're going to say restart robot, and then this guy is actually, we can see the melters on. So now this is my set target temperature, which is going to be 890 degrees, and right now the current temperature is 78 degrees. This is the count in the box, so 158. That's how many are inside the box right there. And then we are going to go to it has to do 2,202 more caps to fill up this box. I just fill up the caps, fill up the boxes, and then once they're filled up, then what I do is I portion them into 500 count bags, and then that's how I keep them. Most of them we use, some of them I sell to people because it's a big problem. Like, it's hard to make those holes, so I figure why not help somebody out. Okay, so here's the teach pendant for it. Here's the main controller for it. So we're just gonna go ahead and turn it on. And now it's just gonna go through its cycle start. It's gonna do its booting. It takes a while for it to do that. So while it's doing that, what the robot's gonna do, so this is a gripper right here. So it actually grips from the outside. It comes in about right here, comes in, opens it, comes around, comes about down here. It's gonna close the gripper, so the cap will fall and it will try to be as level as possible. And then it'll reopen the gripper, it will poke the holes in it, or burn the holes in it, come down, wait a little bit, because what happens is if you move it too quickly, that liquid part, that when you're melting the plastic, that part is still liquid. So if you move it, it'll actually sway and it'll freeze that way. So I wait a little bit, it'll settle, and then move over, blow a little bit of air onto it, come down here, drop it, and go get the next one. All right. So now we're 115 degrees. The robot's ready to go. Basically, it's waiting for me to actually make it press start, but we're gonna come down here. This is to enable the motors. So the motors are enabled. It has two functions right here. This is automatic function, and this is hand operations. That's when you move it by hand. That's when you want to jog it one axis at a time, or linearly, or around a certain object. Okay, it's ready to go. So, and you can hear it turned on. So this is the pointer of what it's reading. So it's waiting for an input 1, and that's actually being controlled by my PLC back there. The PLC is going to make sure that we're within 20 degrees of my set target temperature. So once it reaches that, it will tell the robot to go ahead and go, because right now that melter is only at 148 degrees Fahrenheit, and that's not enough. So we're gonna go ahead and wait for it to heat up. All right, now that we're back, it's all up to temperature. The fan is on. You can't hear it, but believe me, the fan is on. Now we're gonna start. I'm just gonna have to start the robot. I'm gonna push start. So it's waiting for it. It already has the go ahead from the PLC. So what we wanna do is that I'm gonna tell it to, okay, go ahead and start running. So it's gonna go ahead and pick it up, come around, drop it for a second, go up, melt it, wait just a little bit, blow it off, and there we go. And there it goes. And it's just gonna pick one at a time all the way down. I made this thing too big, I can't reach it. I could technically move it over, but it can already hold about 400 of them in here, so it's enough. And it's just gonna keep doing over and over. Here's the program running. So this is, the pointer is where it's reading, and then it has a little robot symbol actually where it's at, where the actual, what position we're actually at. Interesting thing happened. First of all, my battery died, and second of all, the temperature dropped because I didn't tell it to go. So my PLC and my robot only talk through one input, one output. So what happens is that if the robot opens and closes the gripper through the PLC. So the PLC is actually controlling the air valve to open and close the gripper. Now, if the PLC does not see the robot cycle itself within like 2 to 3 minutes, what it's going to do is going to shut everything off. It's not going to tell the robot it's a green go ahead, and it's going to start turning off the heater. And then it's going to keep the fan going until it cools down to below 200 degrees, and then it'll turn itself off. So what happened was I paused the robot, and the temperature went down. So I have to tell the PLC to, oh, okay, go ahead, warm it back up, and then restart it. So now the robot paused, it's gonna wait. So it's only about 9 degrees too low, but it's still gonna wait. Another thing I've added a proximity sensor. I think that's what they're called, but there's one here, it's a through beam sensor, and then there's one right over there, and that basically says right there that there are caps. So if I forget or I miss it, that there's no caps, it's just gonna go ahead and wait until it's gonna stop it. Same thing, the PLC is gonna wait. If the robot's not picking it up within 2 minutes, it's gonna shut everything off, and the robot will just wait for the input to turn on. So basically, it's a fail-safe. So, all right, and this was my slides. These are my slides for the caps, so you can see them. The reason I have this on top right here is so that they don't jump up. So when I drop it, you can see they'll go ahead and slide it down, and then they'll jump. And you can see this one's not very good, but they'll jump like that. Okay, there it goes. There was several ways I could have done this. Mostly I did this because I had the material already, so I made these small channels to hold the caps out of stainless so they can slide easy and I don't have to worry about rust, because then they won't slide because it's rusty. I also made it so you can't put them in upside down, like they literally physically won't fit. So I just go ahead and grab a couple and then I just slide them down. It doesn't interfere with the robot, so the robot can keep going. It doesn't care because we're operating from the other side. All right, guys, thanks for watching, and I'll see you on the next one.